Last class we discussed about elliptic curve or a Galois field. Okay, so we discuss all the component, all the things regarding this. Okay, now we discuss here analog of Diffie-Hellman key exchange. Okay, this is one of the public key algorithm provide a key exchange approach between two users. So in this protocols, we have following parameters. Say, let's p uh, is prime, and select a large integer q, either prime or to the power n. Here q either prime or to the power n. Means this q in the form of the element of the Galois field or a large prime. Then we have a elliptic curve. Y square mod p is equals to x cube plus ax plus b mod p. This is equation 1. Okay. Now, on elliptic curve, this neighborhood index EQAB. Pick a base point of elliptic curve. This, oh sorry, we write here this p, not this q. This is p. We take a base point on elliptic curve from very large order. Means G is the base point or a generator of a collection on an electric car. Okay, then this property is held, and into G is equals to 0, where n is the order of G. This means order of G equals to n, where n is large, and this point is your asymptotic point or a 0 at meet at infinity on an electric car. This G is the base point of an electric car, and in the order of this base point, 0 is the asymptotic point. How to develop this key exchange between Alice and Bob? Say is Alice, say is Bob. Okay. So see, they are following phases. Phase one, global public elements. There are some global public element. So choose here electric car with parameter a, b, and q, where q is the prime or the form of 2 to the power n, or g is the base point on electric car of large order. Again, for user A, key generation, select a private key and a, which is less than n. Calculate a public key. Say I write that here PA is equals to NA into G. This is your actually this is a square multiplication on an electric car. Similar time, user B, yeah, go generate a key, select a private key and B, which is less than N, and select, oh, sorry, calculate a public key, PB equals to N into G. This is G. Okay, then calculating share key. Calculating share key, say this is your calculation of the secret key by A, K equals to NB into PB. Okay, calculating secret key by B. Oh, sorry, this is a and A into PB. It means is calculate is and A into PB, and this calculate K equals to and B equals to P. This is the public key of B. This is the public key of A, or this is the private key of A. This is private key of B. Okay. The key establishment is NB equals into PA is equals to NB into this is the value of PA. PA is equals to NAG. This is your NPB. This is PB. PB equals to and B into G. So this equals to and A into G. Okay, this is the key establishment between Alice and Bob. Okay, directly this is simple approach of the generation of key. I'm repeating now. Okay, these are the phase how to choose a parameters. Now key generation by A and key generation on B. Clear that G is the base point of electric car. This is the scalar multiplication on electric car. Similar way in for Bob side and calculating the share key is this. So this is your key exchange protocol. See this example. Okay. See this example. Uh, if we choose P equals to this you have electric curve with this form. Okay. This means this electric curve in the form of y square equals to x3 minus 4, where a equals to 0 or b equals to minus 4. And given this base point 2 2, then then the value of 24 g equals to 0. So means your n equals to 240. Okay, your n is equals to 240. Then private key. Then the private key is choose n equals to 121, which is n a. This is 121 less than n. This one and public calculate public key is p into p a equals to n a into g. Your n a is 121 into g means 2 and 2. So means you calculate this scalar product on a this electric car. Okay, you know how to calculate 121g means 121g. You first calculate 2g, you calculate 3g, 5g, 10g, 20g, okay, like that. But I suggest to you in exam you will got a simple question, simple calculation, not such type of calculation. This is very very typical. With the help of simple calculation, not easy to calculate the value of n a and n b. Okay, then I'm writing here n a equals to 121 into 2 2 is value is this. This is the value which is calculated by computer, not by hand. Okay, actually there is no possibility to use a calculator. Okay, because we are working in order pair. Okay, so I suggest you develop your concept how to work this approach in the sense of electric car. Okay, see, then private key of Bob is given is 203, and which is less than n. Then calculate public key, which is n b into g. Which one? This. Okay. Now share secret key is this. Share secret key is this, and A to PB and B to PA. So this is 121 into PB. This is your and A PB. Okay. This value is this maybe this is same 203 into 1154. This value is this. uh, in your repeating now in your exam given a simple calculation and simple question based on this approach, not this question. This is a very, very tough question to you, not easy calculate such public key, this public key and this public key are not a easy in calculation. Okay, so I suggest you develop your concept with the help of this example. Okay, now the last topic today class. Okay, already discussed this topic in my presentation. Diffie Hellman key exchange protocols. Okay, this is similar approach. This protocol have a following phases: global key public element, user A generation key, user B generation key, calculating secret key by A and calculating secret key by B. Okay, then the share key is this. Okay, now see this global public element. Choose a large prime is q. Okay, and choose alpha which is less than q, or alpha is the primitive root of q. This is new terminology approach here. Alpha is the new primitive root of q. Okay, this is q. Then user a generation key. Select a private key x a less than q. Calculate public key y a equals to alpha to the power a alpha to the power x a mod q. Similar, user b calculate key. This is form of uh, select the private key x a less than q, and calculate public key y b equals to alpha to the power x b mod q. Okay, then calculating secret key by user a, which is says a, which is y to the power y to the power x a mod q. Calculating secret key by user b says k. This is y. I think something y b to the power x. Oh, sorry. This is y a to the power x b. You correct this thing, okay? Y a to the power x b mod q. So say if we choose, say this is k a, this is k b. If we take this k b, then here we see the calculation. Say this is say k a equals to, okay. So k a equals to this value is y b to the power x a from a side, okay. Now this is yb is x to the power alpha to the power xb mod q into the power x a mod q. This may be written as alpha to the power xb x a mod q. This may be written as alpha to the power xb x a mod q. This may be written as alpha to the power x a the whole power xb mod q. Or this may be written as alpha to the power x a mod q to power xb mod q. Or this may be written as, so what is this? This is your kb. What is your kb? So hence k equals to ka into kb. Sorry, k equals to kb. This is the correctness of secret key. This is the correctness of this secret key. Means uh, just a calculated secret key is this is equals to user b calculate secret key kb, both are same. Okay. So what is the importance of this share key? In Alice and Bob choose some private key, some public key, then share a common key for a future communication. The application of this algorithms provide a future communication platform between user A and user B. Okay, this is a simple key exchange algorithms. Now, discuss the simple example here. Okay, example is this. Q is given is this 3 5 3. Okay, alpha is 3. Choose x equals to this, x b equals to this. Then compute yb is this g40. Yb is equals to 240 or 248. Then common secret key is k. Yb to the power x a mod q means 248 to the power 97 mod 353, which is 160. From B side is remaining same. Okay. So hence K A says K A, sorry K B. This is a K A. So here is K equals to K A. Okay. Okay. This is simple calculation, but I suggest you develop your concept. It is not easy you can calculate with the help of your simple calculator or simple calculation. Okay, this is work for done by with the help of sub coded program. with the help of good quality computer. Okay, it's not easy to calculate this value under mod this. Okay, similarly calculate this value under mod this. It will take more time. Okay, if you are comfortable in coding, so I suggest you implement with the help of some language. You done this example, okay? But you develop your concept in your exam. There will be simple question on your paper, okay? Not at style, such a typical calculation, okay? Now, key exchange protocols we already discussed. Now see the how to work, okay? This is how to work, okay? The simple this is user A, say user B. User A generate X a private key, calculate a public key. Okay, then send. Then similar time user A calculate generate a calculate private key, calculate public key, and also calculate this value. Then this value is sent to user B. After that, user B uh, calculate this YB. This is YB. Okay, and calculate share key says KB. Okay, then this value YB is sent to user A. User A and user A is calculate is this. So here the common key is KA equals to K. This is actually key exchange work. How to work the exchange? So simply the exchange work. Select a private key, compute a public key, and send this public key to user B, and user B generate a private key, calculate public key, and calculate a common key. Share key is this. After that, send this public key to user A, and user A compute share key. So where both are keys same. Okay.